Hello everyone, welcome to the another lecture of periodic table class 9, myself Suman Singh. So if you have seen the previous video, we have discussed about the Mendelic periodic table and the concept of atomic number and the modern periodic table, and right. So now in today's class we will discuss about the periodicity in the modern periodic table. Means what? Periodicity means what? We can say the trend, right? So we will discuss about that. You will understand what is mean by periodicity. So we will see what is written here. So as we have seen, we have discussed about the modern periodic table. So there we have seen that the concept of this modern periodic table is based on the atomic number, right? What did the modern, whereas when we have seen the Mendeleev periodic table, that was based on the atomic mass, but the modern concept of, or we can say the modern periodic table, is based on the concept of atomic number, right? So as we can see, when the elements are arranged in order of their increasing atomic number, okay, those having equal number of valence electron occur at a regular interval or period, okay. and and since the number of valence electron of an element show periodicity, the chemical properties show corresponding periodicity. Means what they want to say, that if you are arranging the element in order of their increasing atomic number in a group, or we can say that if we are arranging the element in order of their increasing atomic number, okay, so we can see that we will see a regular trend, or we can say that they will have a equal number of electrons will occur after an every regular interval or period. As you can see, suppose we are arranging like this. Let me say, show you here. Suppose you see that when we are, what we are doing here, we are arranging the table, right? As you can see, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. After that, sodium, magnesium, aluminum, silicon, phosphorus, like this. If you are arranging, what we will so notice that this element, the one which is coming here, this one, the hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. After that, barium, magnesium, calcium, strontium, barium, right? So these are the elements. What they will do, they will show a regular trend, okay. These are the elements, they will show that they have a equal number of electrons in its outermost shell, or you can say that they have a equal number of valence electron, right? So that is why, since they will have a equal number of valence electrons, so what will happen, they will show a same chemical properties, right? So we will discuss this. One example is also given in your book. As you can see, we are taking the example of, we are considering the example of what, considering the example of the first group of the element, which is lithium, sodium, potassium, rubidium, cesium and francium, right? So they will have an atomic number 3, 11, 19, 37, 55 and 87, right? So as you can see here, this one, when we are talking about this, so what we have done, we have just arranged the element like this. As you can see, lithium, sodium, potassium, rubidium, cesium and francium, right? So what and what, when you see the atomic number, their atomic number is like this: 3, 11, 19, 37, 55 and 87, right? So what was the property, what is the similarities within this element? So their similarities is they all are a good reducing agent, okay. Next thing, what we can say, they form a unipositive ions. Means what, like this unipositive ions, if you talk about, suppose this is lithium, okay. So lithium, let me write it clearly. Suppose this is lithium, so what it will do, it will give one electron, okay. It will give one electron and it will convert into Li plus, okay. In the same way, if you talk about the sodium, it will give one electron and it will convert into Na plus, right? So we have seen this like this, right? So these are called what, these are unipositive, means the atom has donated its one electron, okay. So they are good reducing agent. Number two, they form a unipositive ions, right? After that, you will see it is a very soft metal, because if you will get the chance to see this type of metals, especially sodium, you will see in class 12. There is one experiment in that you will see that. So when you will see that time, they are very soft metal. You can easily cut that metals like sodium, lithium and potassium with their with the knife, right? Now next is they are very reactive, right? And thus they form mainly in combined state. They are very reactive, and since they are very reactive, that is why what will happen, they will found in the combined state. As you can see, when you will see the sodium is stored in a kerosene, because if you will have the sodium in air, so it will react with the oxygen present in the air and water vapor, oxygen and water vapor present in the air, and it will start burning. That is why we used to store sodium in a kerosene, right? So that is why they are very reactive, and most of the time they will found mainly, they are mainly found in combined state, right? Now next is they impart a color to the flame when they burn. When we are burning this, they will impart a color to the flame. Okay. Now next is they form hydrides with hydrogen and oxides with oxygen. Okay, just like they will form hydrides with hydrogen, just like you can take the example of LiH. Okay, and they will form a basic oxide with oxygen like NaO. Okay, or MgO, like this. Sorry, MgO is for second group, but NaO, KOH is like this. You can like this they will form. Okay. Now after that, they will react with the water to form metal hydroxide and hydrogen. Okay, metal hydroxide means what? If we are reacting sodium with H2O, so what it will form? It will form NaOH plus H2. It will form NaOH, okay, plus H2. Okay, so like this way, I hope you have understood. So these are some of the examples. Okay, so as you can see, whatever I have told you, everything is written here and here, right? As you can see here. Now next we will see all these elements, whatever the elements we have discussed, all these elements have one electron in their outermost shell, as I have already told you. Okay, and so they have a similar property. Just like I will give you one example. Suppose when you talk about the lithium has atomic number 3. Okay, so lithium has atomic number 3. So when you will see the electronic configuration, it will be 2 1, right? Now after that, when you will see the sodium has atomic number 11, so when you will see the electronic configuration, it will be 2 8 and 1, right? After that, potassium, when you take the example of potassium, it has atomic number 19. So when you will see the electronic configuration, it will be 2 8 and 1, right? So as you can see, in outermost shell, all of them has a 1 electron, right? As you can, I hope you have understood this, right? They have a valence electron, they have same number of electrons in their valence shell, right? Now I hope you have understood this, right? So what we can say, all these elements have 1 electron in each in the outermost shell, so that they have a similar property. Okay, now if it is noticed that, if you will notice that the element with the, if you will notice that the element with the similar electronic configuration have a similar property, right? What I have told you, what we have seen, that the element with the similar chemical electronic configuration will have what? Similar properties, right? So thus what we can say, the causes of periodicity is the same number of electrons in the outermost orbit, or reoccur of similarities in electronic configuration. What we can say, what are the causes of periodicity? The causes of periodicity is what? The same number of electrons present in the outermost, sorry, the same number of electron present in the same number of electron present in the outermost cell. Okay, same number of electron present in the outermost orbit. So I hope you have understood this, right? Now we will see next is the silent features of modern periodic table. What is the features of the modern periodic tables, right? So when you will see the features of this modern periodic table, we will see here from here. So this is modern periodic table. Okay, so in modern periodic table, vertical column in the periodic table is called group, and the horizontal rows is called period. Okay, so what is this vertical rows? This one, like this, 1 2 3 4 5 6 7 8 9 10, like this. So these are called what? These are called group, right? These are group. Okay, Now these are called vertical column. So vertical column in a periodic table are called what? Group. And the horizontal rows, this one, this one, this one, okay, like this one, these are called what? These are called period. Okay. Now when we talk about the group, like this, when we are talking about the group, so you will see that, so when we are talking about this group, at that time you can see that, the modern periodic table has 18 vertical column, okay, comprising of 1 1 to 8 and 0. Okay. And note that 1 to 7 are divided into two subgroup, and thereby making the total of 18 groups. So you don't have to uh, go in a very difficult manner, just like 1 2 7, after that each group is divided into two groups. That things you don't need to remember. Just remember that the modern periodic table has 18 group, starting from, as you can see, 1 2 3 4 5 6, like this, right? So there are 18 group, as you can see, right? And when you will see you may number this from 1 to 18, or may you can number this like this, you can number 1a, this group is called 1a, this group is called 2a, this group is called 3b, this group is called 4b, this group is called 5b, this group 6b, 7b. Okay. After that, this 2 is what? This 2 is group 8. Okay. This 3 are group 8. Okay. After that, this is 1b, 2b, again 3a, okay, 4a, 5a, 6a, 7a, and 0 group. Like this you can remember, right? So now so I hope you have understood this. So if you are getting confused, then only remember that there are 18 groups in a modern periodic table, right? No need to remember with 1 2 3 like this. Now after that, the elements of group number 3 4 5 6 7 8 and 9 and 10, okay, just like this you can see here the elements with group number 3 to 12, this one, this element. So these elements are called transition element, okay, and they have two outermost cell incomplete. Okay. These elements, the elements starting from group 3 to group 12, okay, to group 12, these all elements are called what? These elements are what? These elements are transition metals elements, and they have two outermost cell incomplete. Okay. Now next is the element with zero group. This is group number 18, this one, this group, okay, helium, neon, argon, krypton, xenon, and radon. This group is called what? Zero group, or it is also called noble gases, because they have a very stable electronic configuration. Just you take the example of neon. So neon has atomic number 10. Okay. So when you will see the electronic configuration, it will be 2 and 8, right? So as you can see, 8, we know that if there is 8 in the outermost shell, it is incomplete, right? We have discussed about this in the atomic structure. So since the element in the zero group, that is group 18, group number 18, is called what? Noble gases, because they have a stable electronic configuration. Okay. And they are hardly react with other element. They hardly react with any other element, means what? Most of the time they will not react with any other elements. Okay. Since they have a stable electronic configuration, or we can say they have a complete electronic configuration, right? Now next is what we can say that since we know that they have 8 electrons in their outermost orbit, okay, except this helium, and all of them, whatever it is there present here, they all have 8 electrons in their outermost shell, except helium has 2, right? We have a duplet, and now after that, but all the rest is they are completing their octet. Okay. So this was about the period group. Now next, if you will see about the period, so there are 7 horizontal rows in the modern periodic table. Each is called period. Okay. This is first period, this is second, this is third, this is fourth, this is fifth, this is sixth, and this is seventh period. Okay. Seventh period. So the number of the cell present in an atom determine its period, as in the right? Whatever the number of cells, number of outermost, or we can say that number of cells present in there in the outermost, or we can say, well, I'll give you one example. Lithium, we know that atomic number is 3, right? So what will be the when you will see the cell number of cell present, so it will be, this will be the nucleus, this is the first orbit where 2 electron, and this is the second, right? Again, when you talk about the beryllium, there are 4 electron, then also it will show the same thing, because it in the first 2 and in the second it will be 2. When you talk about the boron, first 2 and the second 3, right? When you talk about the carbon, first 2 and second 4, right? The same with nitrogen, first 2 second 5, like this. Means what? They have a, the number of cells present in an atom determine its period. Means what? Whatever the number of cells, how much number of cells present in each of this element will determine its period. Okay, now first of all, what we can say, elements with electrons, elements with electrons increasing arithmetically in the outermost cell one by one till an octet is attained and is placed in the same and is means what we can say, elements with electrons increasing arithmetically, okay, in their outermost cell one by one till an octet is attained are placed in the same period. Okay, and the last element in each period has an 8 electrons except for helium. So we will not talk about the group 1, we will talk about group 2. As you can see, as we are moving from left to right, left to right, you can see that there is an increase in the atomic number, right? First of all, it was lithium was 3, beryllium was 4, carbon boron is 5, carbon is 6, nitrogen is 7, oxygen is 8, fluorine is 9, and neon is 10, right? So as you can see, number of electrons means what, number of atomic number is increasing, and since atomic number is increasing, the electrons present in the outermost cell is also increasing, right? Since the atomic number, as you can see, 3, 4, 5, 6, 7, 8, 9, and 10, since they are increasing, means what, electronic, and since the atomic number is increasing, their electrons are also increasing in the outermost cell, right? So what we can say, element with the increasing arithmetically in its outermost cell, right, one by one till the octet is obtained. Means what, here you will see in neon has octet, complete octet, like 2 and 8, right? So in neon the octet has been obtained, right? And the last electron of each period has 8 electrons in its outermost cell. You can see in case of neon, what I have told you, it has 8 electronic configuration is 2 and 8, right? So means what, its outermost cell is completely filled, right? Now next one, what we can say, the first period, which is hydrogen and helium, is called what, short period. Okay, the first period contains only 2 elements, atomic number 1 and 2, and this is called what, short period. Okay, after the second element, second and third period contains 8 element. Okay, second and third period, it will contain 8 element. You count 1 2 3 4 5 6 7 8, right? Here also 1 2 3 4 5 6 7 8. So second and third period will contain 8 electrons. So these are called what, short period. Also this is also called short period. That was shortest period, and this is called short period. After that, when we talk about the fourth period, so fourth and fifth period contains 18 electrons. Okay, this fourth and fifth period will contain 18 electrons. Okay, it will start from 19 and it will end to 36. After that, it will start with 37 and it will end to 54, right? So this period is called what, long period. After that, the sixth period, and when we talk about the sixth period contains 32 elements. Okay, sixth period contains 32 elements, which is from 55 to 86. Okay, but here you will see from 57 to 80 71 it is written, right? But the 57 to 71 is written here. Why? Because these are called transition element. Okay, inner transition elements, inner transition metals, which is lantinoids and actinoid series. So there 57 to 71 you will get here, 57 to 71 here. Okay, 57 to 71 here. After that, as you can see, 89 to 103, 89 to 103 you will get here. These are called actinoids. Okay, so sixth period also contains what, how many, if you will add this whole and this whole, you will get what, 32. Okay, seventh period with atomic number 87. It will start from atomic number 87 and yet incomplete, right? It is not complete, right? This table is yet incomplete because more and more more and more elements are discovering day by day, right? So now next is, you will see that group number 3, when you will see group number 3 of the 6th period, as I have already told you, group number 3 of the 6th period, this one, this here, there is a set of elements with atomic number 57 to 71, as I have already told you. 57 to 71 here, 57 to 71, 57 to 71 here. So with atomic number, as you can see, lanthanum, right? As it is starting from lanthanum and it is ending to lutetium. Okay, now next is beginning with the lanthanum and starting with lanthanum, which is 57, and ending with lutetium, which is 71, right? Now next is, when you talk about this, again group 3, or we can say the group 3 of the 7th period, this is called actinide series. Okay, so it will start from 89, as you can see, actinum, and it will end to lawrencium. Okay, it will end to lawrencium 103, right? So it's beginning with actinide, and this series is called what? Actinide series, and this is called lanthanoid series. Okay, so I hope you have understood this, right? So when we talk about the lanthanoids and actinoids have a similar property because they belong to the same group, as we have seen, right? They belongs to the same group, right? Their group are same, right? So which group? It is third group, right? Their group are same, so they have a same, and they have a similar property because they belong to the same group, right? Which is group 3, but they are shown at the bottom of the periodic table. As you can see, they are shown at the bottom of the periodic table, right here. So why it is like this? They are shown because they are large in number, and showing them in the main body of the table will distort it. So it means if you will show this in here, it will become difficult for us to arrange this element, right? So that is why we have arranged this. We have given a separate place which is below the periodic table, right? So I hope you have understood this, right? Now next is type of element. As you can see, the next is type of element. So when you will see, element can be classified as a representative element, transition element, inner transition element, or inert gas or novel gases, right? So when we see the classification according to S, P, D and F block is based on the electronic configuration, which we will study in higher classes. Okay, and means actually the electronic configuration which we are learning 2 and 8 like this, 2, 8, 18, 32, this is not the way, just because you are in lower classes, so now you are getting this like this electronic configuration, but you will, when you will go in a higher classes, just like in 11, 12, you will see that the electronic configuration is represented by S, P, D and F, right? Now which one is called representative element, and which one is called transition metal, or you can see from here, the group 1 and 2 and group 13 to 17 are called what? Representative element. Okay, group 1 and 2 and group 13 to 15 is called what? Representative element. Here group 1 is called what? Alkali metal, group 2 is called alkaline metal, group 13 is called boron family. Okay, group 13 is boron family, group 14 is carbon family, group 15 is nitrogen family, group 16 is oxygen family, and group 17 is halogen, right? Now next is, I hope you have understood, group 1 and 2 and group 13 to 14 is called what? Is called what? Representative element. Group 3 to group 12 is called what? Transition metal. Okay, and group 18 is called noble gases. So I hope you have understood this, right? So now what is the main what we can say, what is the main characteristics of this representative element? So when you talk about the main characteristics, they include both metal and non-metal. Here in representative element, with this one and this one, these two and this here, all this, okay, this and this all. So they include both metal and non-metal. Okay, they are in regular gradations from metallic to non-metallic character, as one moving from left to right across the period. If you will move from here to here, you will see that there is a metallic character will decrease. Okay, now next is they form electrovalent as well as covalent compound with non-metal. Okay, now next is what we can say, metallic nature increases moving down any of the 7 group. Okay, if you are moving down the group, you will see that metallic character is increasing, right? Notice this. And here you will see that metallic character is increasing, right? Now next is metal with a good conductor of heat and electricity are present in group 1 and group 2. Okay, the metal with a good conductor of heat and electricity is present in this group, this one and this group 1 and group 2, right? And the non-metal character which is present in group 16 and 17. The most non-metallic character you will find in these two group 16 and group 17. Okay, now some higher elements like tin and lead exhibit variable valency. Some of the elements you will see here, tin and lead, they will have a variable valencies, right? So this was all about the representative element. Now next we will see the transition metal. Okay, group from what 3 to 12, right? The group from 3 to 12, this element, we will talk about this. Okay, we will talk about this element. So all these elements are metals with a higher melting and boiling point. First thing. Next thing, what we can say, they are good conductor of heat and electricity. Okay, now next is some of these elements are attached towards the magnet. Okay, and now next is most of these elements are used as a catalyst. Catalyst is what? It is the substance which is used in the reaction to speed up the reaction, but it will not get used in the reaction. Means what? Catalyst means the substance which we are using to increase the rate of the reaction by itself without getting used. Means what? We can say that it will not use, catalyst will not take part in the reaction, but it will increases the rate of the reaction. Okay, so most of these elements are used as a catalyst in most of the reaction. Now most of these elements will exhibit a variable valency, they will have a variable valencies. Okay, and most of these elements are colored ion and colored compound. Most of them will be colored ion and colored compound, right? Now next is inner transition element, which is called F block. As you can see, F block is this one. Now again, one more thing, you will see that this element 1 and 2 is called S block, right? And this element 3 to 12 is called D block element. Okay, and this is called 13 to 17 is called, and 13 to 18 is called P block element. Okay, and now when you will see the F block element, it will be the element of the 6th and the 7th period of the group 3, which is lantinoid and actinoids, are collectively called inner transition element or called F block element. These are what? F block elements. Okay, so this element is found in, as you can see, group 3rd, group 3 of 6th period and group 3 of 7th period, right? So these are called what? Actinoids and lantinoid series, and these are called, they are also called inner transition metal. Okay, so what is the main characteristic of this reason of this element? So the main characteristic is they have a very high, they are heavy metals with a high melting and boiling point. Okay, and they show variable valencies. Now next is they form colored ion. After that, what we can say, actinoids are all radioactive by nature. When you will see these actinoids are all radioactive by nature. Okay, now next, the one is last one, which is called zero group, or it is also called inert gases. Okay, so when you will talk about this group, so when we talk about this group, So these element, it's also, these are also called zero group or group 18, or it's also called inert gas or novel gases. Okay, so they have 8 electrons in their outermost shell, except for helium, this one, which has 2 electrons in its outermost shell, and they do not react with other element, and therefore it is called inert gases. Okay, so I hope you have understood this. So what is the merit of this modern periodic table? So what are the advantages? What we can say, that the first advantages, we can say that it is based on the atomic number, right, which is an even a better fundamental properties compared to atomic mass, right. Now next thing, what we can say, the position of element in the table is related to the electronic configuration. Whatever the position which is given here, the element, the position of the element is based on their electronic configuration, right. Now next is show a regular change in the properties of element on moving across the period or down the group, right. We have learned that, right, if you will move down the group or across the period, the property will change gradually. Okay, so this was all about the merit of the modern periodic table. So one more thing is the properties that reappear at a regular interval of time, or in which there is a gradual variation, or we can say increase or decrease at a regular interval of time, is called what? Periodic property. Okay, and the phenomenon is called periodicity of the element. As you can see, the definition is given here. You can see the definition is given here. So the properties which, the properties that reappear at a regular interval, or in which they gradually there is a gradual variation, means what? Either there will be an increase or decrease in the regular interval, is called what? Periodic property, and the phenomenon is known as what? Periodicity of the element, right. Now what is the causes of periodicity, or we can say what the causes of reoccurrence of similarities in similar electronic configuration. So as you can see, in a particular group, the number of electrons in the outermost shell remain the same, right. We have seen the group 1, group 2, 3, like this, they have the same number of electrons in the outermost shell. So what we can say, the electronic configuration is similar, right. Since they have same number of electrons in their outermost shell, that is, then what we can say, their electronic configuration is also similar, right. So since their electronic configuration is similar, their valencies will remain same, right. Their valencies are also same, right. So what we can say, the element of the same group having a similar property, and though the number of cell increases down the group, right. Since as we are moving from top to bottom, at that time you will see that the number of cells are increasing, right. But since the number of cells are increasing, when you will move from left to from down the group, as you can see here, as you can see here as you can see, if as you will go down the group, so number of cells will increase, but since the number of cells are increasing, but the electrons present in the outermost will remain the same. That is why the there, what we can say, valencies remain same, though the element of the same group have a similar, since their valencies are same, so what we can say, the elements of the same group have a similar property, right. So thus the number of cell increases down the group. Now next is what we can say, modern periodic table is easier to remember, understand and reproduce, right. So it is very easy as compared to other periodic tables. So this was about the modern periodic table. Now we will see some of the defects. We know that everything which has a merit, there is a some there is a demerits. So first demerit, the same demerit which was with the Mendeleev periodic table. What is the position of hydrogen? So position of hydrogen is not still satisfactory, as a property is related to both group 1 and group 17, right. Now next is it fails to accompany the inner transition element, which is lanthanoid and actinoid, in the main body of the periodic table. So as you can see here, it failed to place this failed to place this one here in this group, right, in this group. So this was also a demerits of modern periodic table. So I hope you have understood this, right. Today's class you have understood. So from the next class we will start with the general trend of the modern periodic table, right. So till that, thank you.